Hey guys, so today we're going to be talking about theoretical and percent yield of chemical reactions. In order to do this, we're going to have to do some stoichiometry as well as some limiting reactant type problems. So make sure you review those videos first if you need to go back and refresh your memory on those techniques. So first of all, let's start with some definitions of each of these two terms. Now, theoretical yield is if everything worked out perfectly and every single molecule of our limiting reactant fully reacted to produce the product we're looking for, how much product would theoretically be produced from that reaction? The percent yield is that in a real world situation, not every molecule of reactant is necessarily going to react perfectly, and it will not always react to yield the exact same product. For this reason, we never are going to be able to produce exactly what we predict. The amount that we produced compared to the amount that we predict, we call our percent yield. The equation for solving this is simply how much did you actually make versus how much did you expect to make. In other words, observed over expected. Observed yield over theoretical yield. So let's start by doing a practice problem together where we're going to look at the percent yield of a chemical reaction. All right, so our first practice problem, we're going to look at a chemical reaction, which I show you here is already balanced. Now this is the reaction between iron 3 phosphate and sodium sulfate. And what we really care about on this problem is finding out how much iron sulfate is produced from this reaction. So we want to first find the theoretical yield of this chemical reaction, assuming that we start with 25 grams of our iron 3 phosphate. In order to solve this problem, what we're going to do is we're going to solve for the theoretical yield of our iron sulfate using stoichiometry. So we take our 25 grams of our iron 3 phosphate, divide by the molar mass of iron 3 phosphate, which is 150.81 grams per mole. Then we're going to multiply by our mole ratio of iron sulfate to iron phosphate. This is 1 mole of iron sulfate to 2 moles of iron phosphate, followed by multiplying by the molar mass of our iron sulfate, which is 399.88 grams for every 1 mole. Multiplying across the top and dividing across the bottom, you see that our answer is 33 grams of iron sulfate would theoretically be produced from 25 grams of our initial reactant. This is our theoretical yield. Next, we want to solve for our percent yield given the fact that only in a real reaction, 16.5 grams of our iron sulfate were actually produced. What we do is we simply take our 16.5 grams of iron sulfate actually produced, this is our observed amount, and divide it by our theoretical amount that we just found, that 33 grams. We need to multiply that by 100 to get it to percentage, but our result is 56% yield of this chemical reaction. In other words, we produced only 56% of what we theoretically should have if everything had worked perfectly. So in this chemical reaction, we have found our percent yield, all right, and our theoretical yield. In the next example, I want you guys to try it on your own. All right, in this practice problem, I want you guys to try it on your own. Here we have a balanced chemical reaction between aluminum hydroxide and hydrochloric acid. Now, I'm giving you the fact that we had originally 50.3 grams of aluminum hydroxide reacted. Now, at the end of the reaction, we've been able to isolate 39.5 grams of aluminum chloride. This would be our actual yield. Now, I want you to take these values and I want you to tell me, number one, what was the theoretical yield of aluminum chloride? And then given the value that we observed, what is the percent yield? Pause the video, try solving it. If you find an answer or get stuck, unpause the video and we'll solve it together. Okay, so now you've had a few seconds to solve. Let's go through it together and make sure you got the right answer. So we start with 50.3 grams of our aluminum hydroxide. We're then going to divide by the molar mass of aluminum hydroxide, which is 78 grams per mole, followed by our mole ratio, multiplying by our mole ratio of aluminum chloride to aluminum hydroxide. This is 1:1 based on our balanced chemical reaction. We then multiply by the molar mass of aluminum chloride, which is 133.34 grams per mole. This means that we would theoretically produce 86 grams of aluminum chloride from 45.3 grams of aluminum hydroxide. The second part of this problem was to find the percent yield, given that we produced 39.5 grams in an actual real-world chemical reaction. All we're going to do here is we're going to take our 39.5 that was actually observed, divide it by our 86 that would have theoretically been produced, multiply by 100 to get our percent yield, which is 45.93%. This means that we produced 45.93% of what we would theoretically have produced in an otherwise situation. We can also do a practice problem where instead of finding the theoretical and percent yield given actual data, we can try to predict how much the yield would actually be given a known percent yield. And this is very common in industrial chemistry situations where there's a known chemical reaction, which in certain conditions we know what is the percent yield. And in this case, we need to figure out how much would actually be produced from a chemical reaction. So here we have a combustion reaction between propane and oxygen. And what we're going to need to figure out is, given the fact that we know we have an 81.3% yield, what is the actual amount of the carbon dioxide produced from this chemical reaction? So we need to start with stoichiometry. Given the fact that we have 91.3 grams of our propane initially, we're going to divide by our molar mass of propane, which is 42 grams per mole, multiply by our mole ratio of carbon dioxide to propane, 6 to 2, and then multiply by the molar mass of carbon dioxide, which is 44 grams per mole. This gives us our theoretical yield from 91.3 grams of propane, and gives us the fact that we would theoretically produce out of this chemical reaction 286.9 grams of carbon dioxide. Now, if we know that there's an 81.3% yield, we're going to plug these values into our percent yield equation, where 91.3 is equal to x, or our actual observed value, divided by our theoretical yield of 286.9. We solve for x, remembering that this is a percentage, not a proportion, and we get the fact that x is going to equal 232 grams of carbon dioxide produced. This means that given a reaction of 91.3 grams of propane, in a real-world scenario, we should observe 232 grams of carbon dioxide produced as a result. So that wraps up this video. Let's do a quick recap. Today we discussed percent and theoretical yields. You want to make sure that you know how to utilize these in our actual real-life experimental scenarios, and in many labs this year you're going to see these pop up. So make sure that you're very familiar not just with the definitions, but also how to solve for them. Now, I'd like to thank Brian Gay for writing, producing, filming, and editing this video. Thank you guys so much for watching. I'll see you in the next one.